All right, we're in our note sheet, and I'm going to add to the unit circle trig note part, and we're going to be graphing sine and cosine graphs. So we left off, we were solving trig equations, and we've been doing all kinds of equations and evaluating and things like that. This is different. We're going to be graphing. But it is definitely, we need to know all of the things that we have been talking about with our evaluation. So we are graphing sine and cosine. And we're going to focus on, really three parts of it. So the midline, what's called the amplitude, and the period. So that's going to be our focus for today. It's going to take us a couple days to get really good at this graphing stuff for sine and cosine. When I say graphing sine and cosine, what I mean is we have been talking pretty much unit circle stuff. And I'm going to do how I try and start most of our lessons. I'm going to draw the first quadrant. I know that this is pi over 6, pi over 4, pi over 3. And this is 1/2 and root 2 over 2. Whoops. Not root 2 over 2. Well, I don't want to mess these up. I'm going to first write down 1, 2, 3 to make sure I get them correct. So the first one is 1/2 root 3 over 2, and then root 2 over 2, root 2 over 2, and then root 3 over 2, 1/2. And, well, this at pi over 2, we have the coordinate 0, 1. So I want you to think about the y values. We're going to graph a sine function. What happens to the y values if our angle is going this way? Okay, around the circle. So let me start that again. Our y values are getting larger and larger and larger and larger and larger until they get to 1. And then they get smaller and smaller and smaller till they hit 0. And then they go negative down to -1. But then they start increasing again until they get back to 0. And then they start over again. Okay, again, if we want to graph the sine graph, so I'm going to make a chart over here. And on the top of the chart, my inputs I'm going to do at 0 radians, and let's do the quadrantal angles at pi over 2, pi, 3 pi over 2, and 2 pi. So as we're moving around the unit circle, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that's my angle on top. And on the bottom, I want to find the sine of those angles. So the sine of 0, well, remember the coordinates here are 1, 0. The sine is the y value. So the sine of 0 is 0. So I'm going to fill in this chart here, okay? In fact, I'm going to write that in red, that the sine of 0 is 0. The sine of pi over 2 would be 1, because it's the y value at pi over 2. The sine of pi, which would be right here, is going to be 0, because it's the y value. And maybe it would be helpful if I wrote those on there for you. So, the coordinates here are negative 1, 0, right? And down here would be 0, negative 1, because I also want the sine at 3 pi over 2. All right, do you have any questions for me yet? So I did the sine of 0 was 0. The sine of pi over 2 is 1. The sine of pi is 0. And then the sine of 3 pi over 2 is negative 1. And then if I keep going around, they're going to start over again, okay? So if like this is my angle, I have my sine here was 1. My sine here was 0. My sine here was negative 1. But they're going to start over again here, and then 1, and then 0, and then negative 1. It's going to keep going around and around and around. So I don't need to do all that stuff. I'm just going to draw a basic graph of this, but a linear graph. So I'm going to draw an XY axis. And on that graph, on the x-axis, those are going to be, my x values are going to be my angle measures. So I'm going to put 4 notches here. I had pi over 2. I had pi. I had 3 pi over 2. And then I had 2 pi. So along my x-axis, again, I have pi over 2, pi, 3 pi over 2, and 2 pi. And so for my y-axis, well, notice that 1 was the tallest or the largest value that was here, and negative 1 was the smallest value that was here. So the graph is gonna, the y-axis will be from negative 1 to positive 1. So here is what my sine graph is going to look like. It goes through 0, 0. Okay, that's that point there. Pi over 2, 1. Okay, that's there. Pi, comma 0. Okay, that's this point here. Three pi over 2, negative 1. And then at 2 pi, it's 0 again, and it starts all over. So when I connect those, it's not straight lines. It's curved. It looks like this. It curves and bounces and goes down and curves and bounces and goes back up like that. That is one section or one time around the unit circle for the sine graph. Okay, that is one called period. of the sine graph. Because the sine graph is periodic. Periodic means it's going to repeat. So I'm going to take that and shrink it down just a little bit here, because this is one period of the sine graph. If I went, so that's going around here one time. If I went around again, the graph would do the same thing. And then it would do the same thing again and again and again. The sine graph actually goes on forever. So like the yellow part would be one period, then it would have another period, then it would have another period, and so on. So each of these waves represents one period of the sine graph. So it only hits 0, 0 once, yes. And that's also because it's a function. Remember, for every input, there can only be one output. So good question. Any other questions? All right, well, we probably shouldn't leave the cosine out. So I'm going to go back and I'm just going to add to this chart. And I'm going to make the cosine. Remember, the cosine are the x values. So I'm now looking at the x values. So this 1, and then this 0, and then this -1, and then this 0, and then those repeat. So the cosine of 0 is 1. The cosine of pi over 2 is 0. Cosine of pi is -1. The cosine of 3 pi over 2 is 0, and then it repeats. And it would start 1, 0, -1, 0, and so on. So for a cosine graph, I'm going to draw that right underneath the sine graph. So I'm going to use the same notches I did for the sine graph. So that would be pi over 2, pi, 3 pi over 2, and 2 pi. And my range will be from -1 to 1 also. So it looks, the setup looks very similar to the sine. We're using the same graph basically. All right, and now for the cosine, I'm using these values. So the cosine of 0 was 1, and the cosine of pi over 2 was 0. And at pi, we had -1. At 3 pi over 2, we had 0. And at 2 pi, we had 1. So remember, it's curved, it's not rigid, it's not a V shape, but the cosine graph looks like this. Looks a lot like the sine graph, but it's offset. It's a phase shift. But again, this would be one period of the cosine graph. And then it would repeat itself and repeat itself and repeat itself. So what we have here, these are like our parent functions, okay? Those are the basic sine and cosine graphs. Now, are there any questions on those before we start to look at how we might manipulate that at all? All right, well, we could take a sine graph, and you don't need to write this down, but sometimes you have a sine graph and might look like this, but sometimes it's shifted, up or down or left or right. But if it's shifted, to be able to kind of find what's called the midline is helpful for that vertical shift. So we're going to practice finding that midline for some shifted cosine graphs. So just stick with me here. You don't need to go to this just yet, but I'm going to open up a link here to finding a midline. I'm going to do a couple, and then I'm going to have you guys do a couple as practice. So if we want to find the midline of this sinusoidal graph, that's a hard word to say, sinusoidal. That means the line that is right in the middle of the graph. Well, I look at this graph and it's not exactly centered on the x-axis because I look at the y values. This is up here at 7.7. This is down here at negative 6.7. Like it's not symmetric there about that x-axis. It's a little bit higher up than it is further down. So the midline would be right in between those two. All right, how do I find the exact number right in between 7.7 and 6.7? Well, that's the average of two numbers, isn't it? I mean, I could take 7.7. I mean, how do you find the average of two numbers? You add them together. So plus negative 6.7. Divided by 2. Add them together and divide by 2. And we're going to get 1/2. Sorry about that. I lost my recording there for a second. But we have y equals 1/2. Okay. Let's try another one here. Now this one, I can see that the bottom is at negative 5.2 and the top is at negative 3. All right. So, well, what number is right in between negative 5.2 and negative 3? Well, how would we find? I could, looking at doing this in our head here, it's a distance of 2.2. Half of that would be 1.1. So that would put me at negative 4.1. And that would be the midline. Y equals negative 4.1. That would be this horizontal line. All right, so it looks like we got some decent practice on the midline using the Khan Academy. So let's go back to our notes here and then talk about the amplitude. And we had a good question during the midline because the word amplitude came up. And so the amplitude can be described this way. Let's say we have the graph. And I'll make another sine graph, but it could be a cosine, okay? But if we had a sine graph and it was up like that. Now you guys just found the midline. So the midline, goes right down the middle of it, hence the name, of course. Well, the amplitude of the graph is the distance from the maximum to the midline, okay, or the distance from the minimum to the midline. Okay, so it has to do with the midline. It's like how far away is the min or the max from the midline? But because it's a distance, it's always a positive value. Okay, it's just saying how far away is it from the min or from the max. So let's do a couple of examples. Then hopefully these will clarify that a little bit. And then I'll have you guys practice a couple in finding the amplitude. All right, so come on here, Khan Academy. There we go. All right, so if we want to find the amplitude of this function, here's the midline. It gave us the midline is going through this point. The x value I really don't care about. I care about the y value. The y value is at negative 10.1. And it goes up to a y value of negative 2.7. The amplitude is the distance from this y value to this y value. Well, what's the distance from negative 10.1 to negative 2.7? Well, I could just do, 10.1 minus 2.7, 10.1 minus 2.7, and that is my distance away, 7.4. That is my amplitude of that function. Let me try another one. All right, again, the amplitude is the distance from the midline to either the top or from the midline to the bottom. So another way I could do that is if I know that this is up at 7.7 and that's down at negative 6.7, that means that the distance from here to here would be 14.4. It would be 7.7 plus 6.7. It is a distance of 14.4 from this y value to this y value. Well, the amplitude is going to be halfway in between that. So if I divide that by 2, I get 7.2. That is my amplitude because my midline is about right here. It's 7.2 away from the top and it's 7.2 away from the bottom. So my amplitude in that case would be 7.2. All right, how about if you guys go to our calendar and click on the second practice and start to practice a couple of amplitudes for the next 3-4 minutes. All right, I didn't have many questions on that part. So I'm going to take that as we're understanding amplitude. So if we've got midline and amplitude down, I now want to take a look at the period of the graph. So a period, the graph is periodic, meaning it repeats itself. So again, as I go around the unit circle, I get all the same y values, like all the sine values till here, and then it repeats itself to here, and then it repeats itself again and again. And I didn't even really mention, we also could have negative values, and they would be the same and going this way as well. And so our graph really does go in both directions, in both a positive and negative direction. But a period is how long it takes the graph to repeat itself. So what you want to do to find the period of graph is pick any two corresponding points. So like this point right here and this point right here correspond, okay? But not this one and this one, and I'll tell you why. At this point here, the function is increasing and at 0. And here, the function is increasing and at 0. And here, it's at 0, but it's decreasing. That's why it doesn't correspond. So you have to find two corresponding points. So you could choose those 2 points. You could choose this point here and this point here, okay, 2 local maximums. Or you could choose 2 local minimums. But any 2 corresponding points, the distance between them would be the period of the function. And that's why this function from here to here has a period of 2 pi. So looking at our calendar, if I wanted to practice that a couple times, and this will be our last practice together. I'm just going to do one example, and then I'm going to have you guys do a couple examples on Khan Academy on how to find the period of a sinusoidal graph. So I'm looking at this function. It tells me this, the coordinate is -5, 2.5. I'm concerned about how far, so the x value. But it's not from this x value to this x value. It's from here to here. So I know that from -5 to -1.7, well, that is a length of 3.3 from -5 to -1.7. That's a length of 3.3. And so then if I did -1.7 plus 3.3, I'm going to get 1.6. Now that is the x value here, not the period. I now need the distance from 1.6 to -5. Well, that's going to be 1.6 plus 5 because we're talking distance here, which of course is 6.6. So that would be my period. So I found 2 corresponding points and found the distance between those 2 points. All right, now time for you guys. Take the next 3-4 minutes to practice on Khan Academy.